Okay, welcome back to lecture 21.2, where we're going to have a summary of our potentials and Maxwell relations. Okay, so I'm going to make a big chart of all of our potentials and our Maxwell relations. So let's start by writing the potential. We're going to write the potential. So we're going to write the differential. We're going to write the variables, the thermodynamic variables. That results from those. And I'm going to write the corresponding Maxwell relation. Okay, so we typically start with the internal energy. Which we note as U. And what are the natural variables for U? You should be able to remember this one by now. They're S and V. Okay, from this we can write our differential. du is T ds minus P dV. Now, how to keep track of that sign? Well, I'm just going to try to remember it. I've got a little trick, but because this is our central theorem, I just remember this central theorem. And I can figure out all the rest of the signs from there. But we're also going to do in the next lecture something that's going to help you remember the sign of these differentials. Okay, from this I can get my thermodynamic variables. Thermodynamic variables. All right, so the first one we had was T was partial U partial S at constant V, right? Because it have to be, T has to have the S on the bottom because it has an S here, right? And P was minus partial U partial V at constant S. And our Maxwell relation came from the mixed partials. So our Maxwell relation is going to be partial T partial V at constant S is minus partial P partial S at constant V. Okay, let's do the next one, which is our enthalpy. Remember, this had the same S, but had a P instead. So our dH was going to be the same TdS, but now it's going to be plus V dP. Our Maxwell relations, our thermodynamic variables should be T is partial H partial H partial S at constant P, and V is going to be partial H partial P at constant S. And our Maxwell relation came from the mixed partials. So that was partial T, partial P, and constant S is partial V partial S at constant P. Our third was our Helmholtz. This was F was T and V, right? Just switching my thermal variable instead of my mechanical one. So then dF, I'm going to switch my thermal one instead of my mechanical one, and that switches the sign. So minus S dt and minus P dV. From this, I can actually write my thermodynamic variable. S is minus partial F partial T at constant V. And P is minus partial F partial V at constant T. And my Maxwell relation from my mixed partials is going to be partial S partial V at constant T is equal to partial P partial T at constant V. And finally, our Gibbs was G was T and P. So our differential dG was minus S dt plus V dP. So our thermodynamic relations, minus S, so S is minus partial G partial T at constant P, and V was positive partial G partial P at constant T. And finally, our Maxwell relation was partial S, so let's call it minus partial S, partial P, constant T, equals partial V, partial T at constant P. Whew! Now, that's a lot of information. Okay? So how are you going to need to be able to remember this for when you're doing your homework or you're doing your exams, right? So you're going to need to know all of this. How are you going to remember all of this? So before we go on and show you some examples, which we're going to do in class using all these Maxwell relations, next time, 21.3, I'm going to show you a cute little technique for remembering all of this information in one spot.